Hi, today we are going to discuss about what is the implicit differentiation. So let us take a look at this small poster. Okay, this is a sharing by MD10. Okay, so what is called implicit differentiation? The definition is mentioned about when a function cannot be expressed explicitly in terms of the other variable, then we call it implicit function. So there are few examples to represent that the implicit function. So before it, maybe you will get confused. What's the difference implicit and explicit? I'm going to show you something as the following. So when you're given y equals to x squared plus 3x plus 5, and the situation for xy equals to y squared minus 3x plus 5. So this one we will call it explicit. Okay, we call it explicit function. Okay. And this one we call it implicit function. So the differentiation toward the explicit function, automatically you will obtain dy dx. So straight away the dy dx is expressed at the left hand side, and then we just applying the basic differentiation. But when it comes to this, you found that there are two terms with y. One is y, another one is y squared. It means they're unable to express, okay, we're unable to express y in terms of x clearly. Okay, that's why we call it implicit function. So implicit differentiation, we are required a few basic skill. So what is the basic skill that we have to know? So let us take a look at some comparison. Okay, so let's see. Okay, when we are doing differentiate x, we get that it equals to 1. Okay, but when we differentiate with respect differentiate y with respect to x, you will obtain dy dx. Okay, it's not a constant y. Okay, the reason why we get a 1 just because it's a rate of change dx over dx, which can be simplified. So when proceed to the second one, okay, when we're doing differentiate with respect to x toward the quadratic, so you get that it's a 2x, and differentiate the x by using the chain rule. So that's why you get obtain 2x. But when we are differentiate y squared with respect to x, okay, we will get something as 2y by using the general power rule, and do not forget to differentiate the function under the power 2, so which is a y. So lastly, you will obtain is a 2y dy dx. So this is something that you have to be careful when we're doing implicitly. The dy dx will not appear directly, but it will be hidden in between. Okay, in between. Okay, so let us look at the example 19 in the lecture notes. Okay, for the example 19, we are given a few function which is in terms of x and y. Okay, so I'm taking the example for b. Okay, so you are given that differentiate the function x cubed y with respect to x. So as you know that x cubed and the y, they are product. Okay, they have the product relation, so we have to apply the product rule. So we will keeping the u, differentiate the y, so you get the dy dx, plus keeping the y, differentiate x cubed, you will get the 3x squared. Okay, if it cannot do directly, it actually is equivalent to x cubed d dxy. Actually, that's the meaning. Plus y, and we are differentiate the x cubed. Okay, which is equivalent to u v prime plus v u prime. Okay, so but normally if you're familiar with the product rules, you can implicitly doing the differentiation directly to obtain the expression. So we need to simplify it because this is just the differentiate, find the derivative of, right? Find the derivative of x cubed y with respect to x. So it means that you no need to express the dy dx as a subject. You just need to simplify it, then that's it. Okay, so the square is on here. Okay, the square is here. So the y without the square. Okay, so this is a question B. So let us look at the question C. How about when you given differentiate, this is something x and dy dx. It's a product relation again, but this time it involves the first derivative. So you were letting the x as a u and then this as a v, right? So automatically it will become, keep the u, differentiate the v. So differentiate dy dx. Okay, and then plus, keep the v, and you have to differentiate the u. So simplify it, you get that this is x, second order derivative, d squared y dx squared, plus dy dx times with 1. Right, differentiate x, you get 1, right? So center the question C. Then how about the question D? Find the derivative of ln xy. What you're going to do? Okay, for me, I will simplify first. Let us make it become differentiate ln x plus ln y. Okay, simplify it by using the law of logarithms. So lastly, as you know that differentiate ln x is 1 over x ln e, differentiate the x, right? Plus, for the differentiate ln y with respect to x, y over y ln e, differentiate the y. So simplify it as you know that ln e is equivalent to 1. Right, and also the dx over dx equals to 1 as well. So lastly, you obtain 1 over x plus 1 over y dy dx. So the example 19 is required the basic differentiation involve the x and y when we applying to the trigonometry, exponential, ln, and even though the polynomial. Okay, so let us take a look at example E. Okay, we are going to differentiate e to the power of x plus y. Okay, so before coming to implicit differentiation, the basic skill toward each type of function, you must be strong. So in this case, as we know that if you want to differentiate exponent, it will be copy back. Okay, using our slogan, copy back, ln base, differentiate the power. Right? So as we know that ln e is equals to 1, so you just copy back the exponent ex plus y. So differentiate x plus y. So differentiate x, you get 1. Differentiate y, you get dy dx. That's it. Okay, and come to the last one. Differentiate a trigonometry function sine x minus y. So differentiate sine, we get a cos. So cos minus y, and differentiate the function under the trigonometry. So copy back the cos x minus y. So differentiate x minus y, we get 1. Differentiate y, we get dy dx. So this example 90 is considered the basic. Okay, it's considered the basic. Okay, in this video, I will introduce you again another example, which is example 20. Okay, for the example 20, okay, it's something about find. Okay, the differences this example 20 and the 19 is, now the question is asking you to find the first derivative, dy dx. If, okay, you are given ln xy equals to exponent ey. So this is what we say that this is implicit function. Okay, so this is implicit function. Even though the question didn't mention about solve by using implicit function or implicit differentiation, but we know that we're unable to express the y as a subject from here. Okay, therefore we are writing it as differentiate implicitly with respect to x. So the left hand side you can get it as a, actually we already obtained from the example 19, isn't it? What is a ln xy? Right, we already obtained from here what is a ln xy. So you can straight away get the answer from here. Okay, which is 1 over x plus 1 over y dy dx, because you already simplify this first, right? So it means from here you simplified it as ln x plus ln y equals to ey. So after that we only write differentiate implicitly with respect to x. Okay, differentiate implicitly with respect to x. So you will obtain 1 over x plus 1 over y dy dx for the left hand side, and the right hand side it will become ey dy dx. So now you have two terms with the dy dx. That's why this is what we say that the dy dx will appear in between. Okay, so now it's time for us to simplify. So it will become 1 over y minus ex, because you are shifting the right side to the left side, and the 1 over x we will move it to the right side and it will become negative 1 over x. Okay, so because we need the dy dx as a subject, so I would like to do something which is make the two terms to become single terms. So as we equalize the denominator, you become 1 minus yex. Okay, oh sorry, it's an ey. Okay, so be careful with it. Sometimes we might make this kind of mistake. It should be ey. Okay, it should be ey. And then the right side is a negative 1 over x. So now it's time for you to bring the fraction to the right side, and then you will reverse. It becomes negative 1 over x multiplied with y over 1 minus ey. So from here we know that the negative, I don't like the negative, so I make it as a y, and then x inside will become ey minus 1. Okay, so these two examples is telling you example 19 is a basic, example 20 is how to differentiate implicitly with respect to x to both sides, and lastly simplify to get the dy dx as a subject. Okay, so that's all for this video.